This video accompanies the 2.1 student companion on parallel lines. So in this Explore and Reason, here we have a diagram. We've got a couple of parallel lines here cut by a transversal, and they've kind of numbered the angles kind of in sequence, sort of like counterclockwise or clockwise around 5, 6, 7, 8, and so on. So we want to look for relationships. So what relationships among the measures of the angles do you see? Well, one thing, we always have vertical angles congruent. So angle 1 and angle 3. So it's congruent. Angle 3 and angle 2 and 4 is going to be congruent. And also we have 5 and 7. And we also have 6 and 8. And those are because vertical angles are congruent. So that's all going to always exist whether or not we have parallel lines. Anytime you have an x, opposite vertical angles are going to be congruent with each other. Now the other relationships that we are expected to notice, get rid of these marks here, are like if we look at 2 and 6, they appear to be the same size. 1 and 5 also. 4 and 8, and 3 and 7. Those all match up as being equal to each other. And we call those corresponding angles. So corresponding angles are congruent. And corresponding angles would be like angle 2 with angle 6, angle 1 with angle 5. We have angle 4 and angle 8, and angle 3 and angle 7. So those are all going to be congruent because those are in corresponding positions. We've got 2 and 6, 3 and 7, 1 and 5, and 4 and 8. They're both on the same side of the transversal line with each other, like 2 with 6 as an example. They're both to the right of the transversal line, and they're both above one of the two parallel lines. So 2 is to the right and above, 6 is to the right and above. If we're looking at 1 and 8, 1 is to the left and above, 8 is, or 1 and 5 rather, 1 is to the left and above, 5 is to the left and above. 4 to the left and below goes with 8, which is to the left and below the other line. So those are corresponding angles. The other thing we have going on is that these angle 4 and angle 6 and angle 5 and angle 3 look to be the same size. And in fact they are. We call those alternate interior angles. They're on opposite sides of the transversal, that's the alternate, and also opposite corners, and they're inside the two lines that are crossed. So alternate interior angles are congruent. Alternate interior, we'd have angle 4 with angle 6, and we'd have angle 3 with angle 5. So those pairs are going to be congruent to each other because those are alternate interior position angles. We also have alternate exterior angles. Like if we look at 4 being congruent with 6, being alternate interior, by vertical angles, 6 goes with 8 and 4 goes with 2. This gives us what we call alternate exterior angles congruent. So alternate exterior, we have, really it's alternate interior with the vertical angles, or we can just make one jump. If they're on opposite sides of the transversal outside the lines that are crossed, we call those alternate exterior. And they're going to be congruent, or have the same measure. So 2 and 8 are alternate exterior, and 1 and 7 are alternate exterior angles. The other relationship that it maybe isn't so obvious unless we kind of think about it a little bit, for these lines here, are these two pairs here, angle 3 and 6. Those are same side interior angles. They're both the same side, right of the transversal, inside the lines that are crossed. Or if we look at the other side, 4 and 5, those are on the left-hand side of the transversal, inside the lines that are crossed. So they're both on the same side of the transversal with each other, 4 and 5, or 3 and 6, and they're inside. We call those same side interior angles. And same side interior angles are supplementary. Which means they add to 180. And so the pairs we have there are 4 goes with 6, angle 4 and angle 6, and angle 3 and angle 5. Okay, so we got the vertical angles, opposite sides of the x. We have corresponding angles, like 3 and 7, or 1 and 5. We have alternate interior angles, like 3 and 5, or 4 and 6. We have alternate exterior angles, 8 and 2, or 1 and 7, and those are all congruent to each other. Then we have same side interior angles, like 3 and 6, and 4 and 5, that need to add up to 180 degrees. The only other angles in this diagram that we haven't really talked about or that we've had in the past are the linear pairs. Like 1 goes with 2. Those are going to be 180. They're supplementary. 2 and 3 are supplementary. 3 and 4 are supplementary. And 4 and 1 are supplementary. So we have linear pairs of angles are supplementary. I'm going to go ahead and note that on there, but not list them all. So we need to also take note of those. So in this diagram, there's lots of different relationships between the angles. If we know one angle, for example, we have enough to calculate all of them. Like if angle 2 is a 30, the linear pair idea means that 3 has to be 150. Vertical angles means that 4 has to be a 30, and then 1 would have to be 150. Corresponding, if 1 is 150, 5 must be 150. If 2 is a 30, 6 has to be a 30. 8 and 6 have to be congruent by vertical angles, so 8 has to be a 30. 8 and 7 are a linear pair, so 7 has to be 150. Or we could look at 7 as being alternate exterior with 1. So there's lots of different ways that we can go about finding all the angle measures in this diagram if we have a parallel line cut with transversals and we're just given one angle measure. Let's look at part B. Suppose a different transversal intersects parallel lines. Would you expect to find the same relationships? Yes, we do. Okay, so let's draw a couple of parallel lines. And let's draw a perpendicular, say, that goes this way now. So this angle and this angle are going to be congruent because these are alternate interior angles. This angle and this angle are going to be same side interior. These are going to have to add to 180 degrees and so on. So the answer is yes for this. Parallel lines cut by a transversal, these relationships are always going to hold. The linear pairs and the vertical angles are going to be there regardless, but if you have the parallel lines with the transversal, corresponding alternate interior and alternate exterior angles are congruent, and same side interior angles are going to be supplementary. Okay, let's move on. So let's look at example 1. We want to identify angle pairs here. See what we have. Which angle pairs include the named angle? So we're talking about angle 4. So we could talk about 4 with 6 as being same side interior. We could talk about 4 and 8 as being corresponding. We could talk about 4 and 2 as being vertical. Let's see what else we got. So we got corresponding. Same side. We did the same side interior. We have corresponding. The only other one is alternate interior. We have 4 with 5. Those are alternate interior. Alternate interior. And that would be angle 4 and angle 5. So the difference, let me get these off of here. So same side interior, these are going to be supplementary. They have to add to 180. These are going to be congruent. Vertical angles are going to be congruent. Alternate interior angles are going to be congruent. So those are the different angles we have in relation to angle 4. If we look at angle 7, okay, here's angle 7. Let's do 3 marks for angle 7. Well, 7 and 3 are corresponding. 7 and 1 are alternate exterior. So these are going to be congruent because those are alternate exterior angles. Or we could have also done the vertical angle with 3 to get alternate exterior. Let's see. Well, I left out linear pairs. 8 and 7 are a linear pair, which also means that over here we could have done linear pair with 4. We could have done 4 and 3. And 4 and 1 would be linear pairs. So because they're linear pairs, not anything to do with parallel lines, but because 4 and 3 are linear pairs, they're going to be supplementary. Because 4 and 1 are a linear pair, they're going to be supplementary. 7 and 5 is a linear pair. 7 and 8 is a linear pair. So we also have 7 and 5 we need to put in there. So we took care of alternate exterior. We got corresponding. We have, I left out the vertical. Vertical angles, we got 7 with 6. We can't do alternate interior because 7 is an exterior angle. And we can't do same side interior because 7 is an exterior angle. So in pink here, we have the different relationships that the angles have with angle 7. Let's look at example 2. Use the figure at the right. If the measure of angle 4 is 118 degrees, so we'll put 118 in there, what's the measure of each of the other angles? Well, let's kind of jump these measures around. Angle 2 is going to be 118 because it's a vertical angle. Angle 8 is going to be 118 because it's a corresponding angle. Angle 6 is going to be 118 because that's a vertical angle to angle 8. Or we could have also done alternate exterior with 4 and 6. And we also have this linear pair thing going on here. 180 take away 118 gives us 62. We could have done linear pairs with 4 and 3, or we could do vertical angles with angle 1, and we get 62 for the angle 3. Corresponding angles with 3 can jump that measure down to 7. That's corresponding. And then we could do vertical angles to go with angle 5, or we could have done linear pair with 8, or we could have done linear pair with 6 and found that that was 62 degrees also. So we found all the other angle measures. Let's look at part B. If measure of angle 2, which is this angle, is 9x minus 12, and the measure of angle 4 is 6x plus 30, what's the measure of angle 5? Now angle 5 is going to be same side interior with angle 2, so the plan would be to find x by setting these two equal to each other since these are vertical angles, finding x, plugging x back into one of these to find out what the actual measures are for part B, and then subtracting from 180 because 5 and 2 are a linear pair. and need to add the 180. So I'm going to set 9x minus 12 equal to 6x plus 30. And that's because vertical angles are congruent. Then take away 6x from both sides. 3x minus 12 equals 30. That'd be subtraction property of equality. Then add 12 to both sides. 3x's equals 42. That's addition property of equality. Then divide both sides by 3. X equals 14. Division property of equality. Now that x is 14, we can find out what each one of these angles is. Let's do 6 times 14 plus 30. So I'm going to use the algebra that goes with angle 4 because the number's a little bit smaller. 60 and 24 is 84. 84 and 30 makes 114. So for part B, these angles measure 114. Now, since 2 and 5 need to be supplementary, if I do 180 take away 114, I get 66. Is that right? 66. Yeah, 66. So the measure of angle 5 is 66 degrees. Okay, let's move on. Okay, so for this one, we want to prove the corresponding angles theorem. So we can't use corresponding angles in this one. We can use the other ones that we were given. So we got the two lines are parallel, and they want us to prove that angle 1 and angle 2 are congruent because those are corresponding angles. So in looking at this, same side interior angles says that the measure of 3 and the measure of 2 adds up to 180. That's because they're same side interior. They're supplementary. And then 1 and 3 are a linear pair. So the measure of angle 3 plus the measure of angle 1 equals 180. And that goes with them being a linear pair. Now we could say that since 180 equals 180, that'd be reflexive property. We can substitute the top one, number 1, in for this left-hand 180. So we have measure angle 3 plus measure angle 2 equals, and on the right-hand side for the 180, we can substitute in equation 2. Measure angle 3, really expression and measure angle 3 and measure angle 1. Since these also are supplementary, we can set them equal to each other. Now if I take measure angle 3 away from both sides, I'm left with measure angle 2 equal to measure of angle 1. And by definition of congruent, if these two angles have equal measures, they're going to be congruent to themselves. So angle 1 is going to be congruent to angle 2. And that's pretty much how the proof argument needs to go to basically show that angle 1 is congruent to angle 2. So these two angles are going to be congruent using the same side interior with linear pairs. We can show that they have to be congruent, and these are corresponding angles, so we can show that corresponding angles have to be congruent. Let me go back. That's a faux pas. Okay, let's look further down now. Okay, so I think I see how the argument needs to go on this one. What I'm thinking about is, okay, so here we have parallel lines cut by a transversal. Here we have a linear pair, and if this angle is a right angle, angle 1 also has to be a right angle, which means it measures 90 degrees. Now, because of the parallel lines, with BC being a transversal, angle 2 and angle 4 have to be congruent because those are alternate interior angles. Also, because of this perpendicular down here at C, angle 3 and angle 4 together also are complementary because they need to make this right angle. So we have the measure of angle 3 plus the measure of angle 4 has to equal 90 because they're complementary here. But angle 2 and angle 4, so the measure of angle 2 equals the measure of angle 4 because these are alternate interior angles. I'll use AIA for alternate interior angles. And since alternate interior angles are congruent, their measure is going to be equal. Then what I'm going to do is substitute the second into the first. So in place of angle 4, I'm going to put angle 2. So now we have measure of angle 3 plus measure of angle 2 equals 90. And from our original diagram, our original statement, we also have that the measure of angle 1 is equal to 90 because it's a supplement with this right angle, and it has to be 90 degrees. 180 take away 90 gives us 90. Now altogether, if we add the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 and substitute all this in, the measure of angle 1 is 90. The measure of angle 2 plus the measure of angle 3 is also 90. So together we can say or see that they add up to 180. So basically we can show that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 90 degrees. So we've shown that in a right triangle, the sum of the three angles adds up to 180 degrees. Let's look at example 5. Okay, let's look at example 5. Let's see, they're giving us a bunch of parallel lines here. So let's start with these two lines being parallel to each other and see what we can do. They're telling us that EJF is 56 degrees. EJF 56 degrees. That's 56 degrees. So let's see. With JC being a transversal line, this angle BFC is a corresponding angle with EJF, and that's going to be 56 degrees. By vertical angles, we know that this angle JFH, if that's an H, is going to be 56 degrees also. And they want us to find out what this angle measure here is down at the bottom. Let's see what we got. Okay, so what else? So we got parallel line. So that's maybe all we can do with those parallel lines for right now. Let me look at a different set of parallel lines. They're also telling us that this EG and AC are parallel with each other. So these are parallel with each other. So here we have parallel lines cut by transversal this way. That sets up some angle pairs. So let's see. Cut by a transversal. This angle is 68, along with this other transversal line here that cuts across these two, sets this angle FEA up as being a same-side interior angle, which means that this is going to have to be 112 degrees. Because together these need to be 180 since same-side interior angles are supplementary. So we're talking about this parallel, this transversal. These are same-side interior angles. Okay, so since this angle is 112, the corresponding angle would be this angle GFB down here. This would have to be 112, which basically means that this has to be 56 because together these need to make 112. That's going to be a 56-degree angle. Now altogether here, 56 and 56 gives us 112. That's going to leave angle 3 as being 68, since all three of these angles need to add up to be 180. Okay, let's look at JC versus KG now. So let me get rid of those parallel lines. And now we're going to look at these two lines as being parallel to each other. This one and this one is parallel. So let's see. So if this is 56 degrees, here we have two parallel lines cut by this transversal. This angle that we're looking for, which is angle FHK, has to be supplementary with this 56-degree angle since they're same side interior. So 180 take away 56 gives us 124. So 56 gives us 124. And the measure of angle FHK equals 124. So this angle right here is 124 degrees. Let's move on. For the do you understand what angle relationships are created? Well, we have a couple of different kinds. You got parallel lines cut by transversal, make the lines parallel. You've got alternate interior angles are congruent, alternate exterior angles are congruent, same side interior angles are supplementary, and corresponding angles are congruent. And then the other ones that we have, regardless of parallel, are vertical angles congruent, and then your pairs are supplementary. So those are all the different relationships that are formed when lines are crossing each other like that. Number two, when a transversal intersects two parallel lines, which angle pairs are congruent? Well, really the alternate interior, alternate exterior, corresponding, and vertical. Those are the angles that can be congruent. So the dots go with number two. Let's look at number three. Okay, so Leah is trying to say that angle 1 is 88 degrees, but that only works if these lines are parallel. These lines are not marked as being parallel to each other, so we can't assume that they are. So that means that we don't know what the measure of angle 1 is. We can't say that it's 88 degrees. It may be if the lines are parallel, but they don't tell us that they are, so we can't assume that they are, and that's her mistake. So they are corresponding angles, but the corresponding angles theorem only works for parallel lines. So her mistake is that those lines are not parallel lines, so you can't use that theorem. Number four, generalize for any pair of angles formed by a transversal. What are two possible relationships? We got parallel lines cut by a transversal. One relationship is that they're going to be congruent. The other relationship is that certain pairs are going to be supplementary. The congruent ones, this one and this one, this one and this one, those are the ones that are congruent to each other. We got like alternate exterior, corresponding, alternate interior. These other ones, other pairs are going to be supplementary. So these, whatever these are they're going to be supplementary to the ones that we just did. So the supplementary ones goes with the dots, and the arcs go with the ones that have to be congruent. Let's go back up top of the next column for the do you know how. Classify each pair of angles, compare angle measures, and give the postulate or theorem that justifies it. So 2 and 6 together are corresponding angles. So corresponding angles are congruent is the postulate. 3 and 5 are same side interior. Same side interior angles are supplementary. For number 7 and 8, they're telling us that the measure of angle 1 is 71 degrees. So let's put 71 in and see what the measure of these angles come out to be. So use say red here. So angle 1 is 71. Corresponding, angle 5 is going to be 71. Alternate interior, 4 is going to be 71, or by vertical. And corresponding, or by vertical with 5, 8 is going to be 71. These other pairs are all going to be supplementary. So this is going to be 109 for 3, 109 for 7, either linear pair or corresponding position. Linear pair or vertical, 109 for 6. And by vertical with 3, or by linear pairs with 1 and 4, we get 109 for the measure of angle 2. So we've got all those different angles that are set up when 1 is a 71. Angle 5 is going to be 71 degrees. And angle 7 is going to be 109 degrees. Okay, for 9 and 10, if 3 and 5 have these different algebra expressions, let's see how 3 and 5 relate to each other in the diagram. 3 and 5 are same side interior angles, so they're going to have to add up to 180. So I'm going to set my angle addition equation down here. My angle addition equation, 3x plus 12 plus 2x plus 3 equals 180. So I get 5x plus 15 equals 180. Take away 15, 5x's makes 165. Divide by 5x is going to be 33. Measure of angle 5 is going to be 2 times 33 plus 3, which is 69. And measure angle 7. I go back up to see where angle 7 is. Angle 7 is supplementary. So supplementary to 69 is going to be 111. So that angle is going to be 111. In here, they're telling us elm and spruce are parallel to each other. If this is 112, this is 112. Angle 1 is going to be supplementary. 180 minus 112 makes 68. So that's going to be 68 degrees.